This is Module 3, Lesson 1 homework, and we're working on making equivalent fractions and showing that on a number line and then just with visual representation in boxes. So for number 1, it says use the folded paper strip to mark points 0 and 1 above the number line and 0 thirds, 1 third, 2 thirds, and 3 thirds below it. So we worked on making fraction strips today, so they should have a reference for this. This would be 0. This would be 1. Oops. Not 0, 1. And then we know that if we have a thirds, we would break it up into 3 equal pieces. So this would be 0 thirds. This would be 1 third. This would be 2 thirds. And this one over here would be 3 thirds. Now it says draw 2 vertical lines and break each rectangle into thirds. Shade the left third of each. Partition with horizontal lines to show equivalent fractions. Use multiplication to show the change in the units. So the first thing it's asking us to do is to divide each of these into vertical thirds. And I told the kids just go ahead and do those with all of them first, so we know that we always have 1 third shaded and that we're not changing how many we're shading. And then we're going to come up with equivalent fractions for each of these boxes. So in this first one, they've done 1 third times 2 over 2 equals 2 sixths. So we discovered that if you cut that in half, you've now multiplied that by 2 over 2 by creating 2 boxes in each third. So if you say 1 times 2 is 2, 3 times 2 is 6, you should have 2 sixths shaded. We have 6 pieces here now, and 2 of them are shaded, so we've done it correctly. We go to the next one. We have 1 third equals 1 third times something over something. The next logical one would be to break this horizontally up into thirds. So that would mean we would say it was times 3 over 3, which would end up with 3 ninths. And to double check, we have 1, 2, 3 shaded. Oop, that's our numerator. 1, 2, 3, 4, 5, 6, 7, 8, 9 as our denominator. We go on to the next one. We have 1 third equals. And the next logical one would be to divide this up into fourths. So we would say 4 over 4. 1 times 4 is 4. 3 times 4 is 12. So we have 4 out of 12 shaded. 1, 2, 3, 4 shaded. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There. And we could go on to do multiplying this by 5 over 5 as well. The next one I wanted to show was number 4. Continue the process and model 2 equivalent fractions for 9/8. Estimate the mark points on the number line. So this is one where we would probably want to say 0, 1, and 2 on our number line. And then we know that each hole needs to have 8 pieces inside of it. So there's 4, 1, 2, 3, 8 pieces there. 1/8, 2 eighths, 3 eighths, 4 eighths, 5 eighths, 6 eighths, 7 eighths, 8 eighths. We have 1/8, 2 eighths, 3 eighths, 4 eighths, 5 eighths, 6 eighths, 7 eighths, and 8 eighths. So, just like before, we're going to divide up these into eighths. It's a little tricky when these get a little bit higher. Okay, so if I know I have 8 eighths in this box, I need 1 more eighth shaded, I would take it from the next box. So I know that I have more than a hole if I have 9 eighths. So if I have 9 eighths equals 9 over 8, let's just do the 1 cut horizontal, which would make this 18 sixteenths. And if we go over here, we can cut this into 8s, cut this one also into 8s. We can shade this entire one here. That's 8/8, and we need one more eighth. We can cut this into thirds. So we have 9/8 equals 9/8 times 3/3, which is 27/24. And we could count those and we would have 27 shaded out of 24 boxes in one hole. And that's how we are making equivalent fractions.